muscular, hollow muscular organ, which is the site of implantation of the fertilized ovum and the vagina, which directs its spermatozoa to the cervical canal. The external genitalia is composed of the clitoris, the labia majora, and labia minora. So included in this discussion is the mammary gland. This is not part of the female reproductive system. However, the mammary glands undergo cyclic changes in relation to the menstrual cycle in pregnancy and also in response to the pituitary and ovarian hormones. Okay. So first, the ovary. So are you having recording? Any recording there? So no recording, please. So the ovary. So the ovaries are paired almond-shaped organs measuring about 3 by 1.5 by 1 cm located in the pelvic cavity, the functions of which are production of ova and the production of steroid sex hormones needed for reproduction. Therefore, the ovaries are considered as endocrine organs. So histologically, the ovary has an outer covering known as a germinal epithelium, and this is composed of a simple cuboidal epithelium and an inner covering known as a tunica albuginea, which is composed of a poorly vascularized, dense, irregular connective tissue between the germinal epithelium and the ovarian cortex. So there are two regions of the ovary. You have the cortex and the medulla. The cortex is the outer region of the ovary, and it contains most of the oocyte containing ovarian follicles. And the medulla, which is the inner region of the ovary, and it is composed of loose connective tissue, stroma, blood, and lymphatic vessels and nerves. So let's now take up the ovarian cortex, which contains most of the ovarian follicles. So there are 4 types of ovarian follicles according to their stages of development. So first you have the primordial follicle, and then you have the primary follicle, and then secondary follicle or antral follicle, and the mature or Graafian follicle. So the primordial, that is primordial follicle, this is the smallest and the simplest ovarian follicle. So it is inactive. It is in its earliest stage, and this is a predominant follicle before puberty. It is composed of primary oocytes surrounded by a single layer of squamous or flattened follicular cells. And this type of ovarian follicle is not dependent on FSH for its development. The second type is a primary follicle, and this is also not dependent on FSH, and it is composed of a primary oocyte surrounded by either a single layer of cuboidal cells or multiple layers of cuboidal cells. And these cuboidal cells are known as granulosa cells. So if it is surrounded by a single layer of cuboidal cells, it is known as unilaminar primary follicle. And it has a glycoprotein-rich zona pellucida, which is found between the oocyte and the cuboidal cells. So this unilaminar primary follicle develops from the primordial follicle. If the primary follicle is composed of a primary oocyte surrounded by multiple layers of cuboidal cells, then it is known as a multilaminar primary follicle. And then the proliferative activity of granulosa cells is due to the substance known as activin produced by the primary oocyte. So in this stage of ovarian follicle development, the oocyte or the primary follicle is surrounded by 2 layers of stromal cells, the theca interna and the theca externa layer. And then the secondary or antral follicle. So this type of ovarian follicle contains cavities filled with fluid known as liquor folliculi. And these cavities gradually coalesce, forming a large cavity known as antrum. Hence, the secondary follicle is also known as antral follicle. And the stage of follicle development, this is dependent on FSH. So there is a small group of granulosa cells or cuboidal cells that project out from the wall into the antrum, and this is known as cumulus oovorus. While those granulosa cells immediately surrounding the primary oocyte, this is known as corona radiata. Okay. And then the fourth type of ovarian follicle is a Graafian or mature follicle. And this differs from the secondary or antral follicle mainly by its large diameter. So this stage of ovarian follicle development immediately precedes ovulation. So it is FSH dependent until it becomes a dominant follicle. So once the mature follicle becomes a dominant follicle, it is not anymore dependent on FSH. So this type of ovarian follicle produces substance known as inhibin. And the inhibin will suppress the release of FSH from the anterior pituitary gland. And with the low FSH level, this will now make the other mature follicles atrophy or degenerate. Therefore, there is only one, usually only one dominant follicle per cycle or per ovulation. So the origin and maturation of oocytes. So your oogonia comes from the yolk sac endoderm, and they undergo mitosis and migrate to the cortex of developing ovaries. So your ovaries, or each ovary contains about 5 to 7 million oogonia. And on the 5th fetal month, the 5 to 7 million will now become 1 million, okay? And they will now enter the first meiotic division and arrested and prophase stage. So the others will degenerate. Okay. So out of the 1 million oogonia, 600,000 will become atretic. 400,000 will reach menarche or the first menstruation of a woman. Okay? And only out of the 400,000, about 450 oocytes are released over the reproductive years of a woman. Okay? So what is now this process of ovulation? So it involves the rupture of a mature follicle and the release of secondary oocyte occurring on the day 14 of an ideal 28-day cycle. So what will now happen on the 14th day or the mid-cycle? So the estrogen from the Graafian follicle and secondary follicles causes an increase of blood estrogen levels, resulting in 1. Negative feedback inhibition, preventing the release of FSH from the anterior pituitary. And there is now a sudden surge of LH, or the luteinizing hormone released by basophils of the anterior pituitary. And this sudden surge of LH will result in increase in blood flow to the ovaries. And the release of a local factor, which is a meiosis-inducing substance. So this meiosis-inducing substance will now trigger the completion of the first meiotic division. And the oocyte now will enter the second meiotic division and arrested at metaphase stage. So until fertilization, the oocyte now will, if there is no fertilization, then the ovum that is released during ovulation will degenerate. Okay? Okay. So what will now happen to the remnants of the follicle after ovulation? So during ovulation, what is released is the ovum together with the corona radiata and zona pellucida. Okay? So what will now happen to the other cells surrounding the oocyte? Like for example, the other granulosa cells and the theca cells. So what will now happen? So, what? Because of the influence of LH, so there is now a surge of luteinizing hormone. And this luteinizing hormone will influence the granulosa cells, the remaining granulosa cells and the theca cells to increase in size. And they will now form the granulosa lutein cells and the theca lutein cells, which compose the corpus luteum. So this corpus luteum is a temporary endocrine organ formed by the remnants of the follicle after ovulation, and this is due to the stimulation by the hormone LH. Okay? So the granulosa lutein cells are modified granulosa cells which produce progesterone, mainly progesterone, and theca lutein cells are modified theca internal cells which mainly produce estrogen. Okay. So with high levels of estrogen and progesterone, okay, there is now inhibition of the secretion of LH and FSH. And without FSH, then there is no development of new follicles. And without LH, if pregnancy does not occur, the corpus luteum will degenerate. If pregnancy occurs, then the corpus luteum enlarges, forming the corpus luteum of pregnancy. Okay, so your corpus luteum produces hormones, the progesterone and estrogen. And this will now prepare the uterus, the endometrium, in case there is fertilization and implantation. Okay, so that is now the role of the corpus luteum. So what is this corpus albicans? So this is a dense white connective tissue scar produced as a result of degeneration of the corpus luteum in the event that no fertilization and implantation occur. Okay, so if there is no implantation, then the corpus luteum will degenerate, forming a scar known as corpus albicans. And then what will now happen to the other follicles after ovulation? So the fate of the remaining cells after ovulation, the remnants of the ovarian follicle, the mature or the dominant follicle, will become corpus luteum. Okay? While the other mature follicles, or while the other follicles in various stages of development, they will undergo degeneration or atresia. Okay, so let's now take up the hormones. So take note of the different hormones there that will influence the ovaries. Okay, so take note of this human chorionic gonadotropin, or HCG. This is produced by the placenta, and this is detected on the 8th to 10th day of or after fertilization. So this is now the basis for the pregnancy test, your HCG, or the human chorionic gonadotropin. And this human chorionic gonadotropin will maintain the corpus luteum until the 3rd month of pregnancy, and the corpus luteum will now gradually degenerate. And the function of the corpus luteum, what is the function of the corpus luteum again? Production of estrogen and progesterone. The function now of the corpus luteum will be taken over by the placenta. So the placenta now will produce estrogen and progesterone when the corpus luteum has degenerated. And this, what is now the role of estrogen and progesterone during pregnancy.